Okay, guys, this is the last example from Chapter 8. Very similar to the one we just did. We want to find the impulse of the force and the average force on the ball, assuming we know the collision time, except now we're just dealing with this in 2 dimensions. So it's important just to remember that impulse is a vector, and so we need to find x component and the y component of the change in momentum of the impulse, and then from that we can determine what the impulse would be, and from the impulse we could determine the average force. So first we can account for the x component of the impulse, or the x change in momentum. The ball starts by coming to the left at 20 meters per second, solely in the x direction. After it's kicked, the x component of its velocity is given by 30 cosine of 45 degrees. And so we can determine the change in the x momentum, (19.97 kilogram meters per second). We'll repeat the same process with the y momentum, but remember that initially there is no y momentum. We need only find the final y momentum. And so we find the change in the y momentum to be 8.49 kilogram meters per second. To find the impulse, we'll just add these two components like vectors, and then to find the force, divide by 0.01. Using the Pythagorean theorem, you find the magnitude of the impulse to be 21.7 kilogram meters per second. And the angle of the impulse is 23.03 degrees. To find the average force, we just know that the change in momentum is equal to the force times time. We find the average force, 2,170 newtons. So what this implies is that if you applied a 2,170 Newton force at an angle of 23.03 degrees to an incoming soccer ball that's traveling at 20 meters per second on the ground, and if you apply that force for 0.01 seconds on average, then the ball should leave your foot at 30 meters per second at an angle of 45 degrees.